Let's move on to the collision theory and the Arrhenius equation. According to collision theory, reactions occur when the reactants collide with each other with the appropriate amount of energy and are in the correct orientation. And the Arrhenius equation describes the relationship among these factors. So that's just going to be this equation here. K is just the rate constant. We've discussed that in the previous section. The capital A is going to be the frequency factor, and EA is the activation energy. And then R is the gas law constant. It's given 8.3145 joules per mole Kelvin, and T is the absolute temperature in Kelvin. The frequency factor, or capital A, is related to how often the collisions occur, and it also is related to the probability that the collision will occur with the reactants in the appropriate orientation. So if a collision happens and it's not in the appropriate orientation, a bond might not even form. So the rate of collisions can be increased by increasing the concentration and, to a smaller extent, increasing the temperature. If we increase the concentration, for instance, we have a beaker with a few particles and a beaker with a lot of particles. What's going to be more likely to have a specific collision? The beaker with the fewer particles or the beaker with much more? Well, there's going to be a lot more collisions in the beaker with a lot more particles present. So that's why increasing the concentration will also increase that factor. And then also increasing the temperature causes that kinetic energy to also increase, and it also makes the probability of those collisions happening too. We already discussed the decomposition of NO to become N2 and O2. So this is what we saw. We have the two double bonds between the nitrogen and the oxygen. We have to break those double bonds, and then a collision has to happen between the two nitrogens and the two oxygens in order to create the N2 and O2. If the nitrogen collides in a different fashion, then a reaction will not happen, or the N2 will not be created, and the O2 will also not be created. So thus, there are many more collision orientations that do not lead to a reaction than there are orientations that do lead to a reaction. So having more concentration and more temperature, or higher temperature, will help that. Example 14.12 says draw molecules of the most likely orientation between reactant molecules for the chemical reaction shown below to proceed successfully to the products. So we're going from ClO and oxygen, and we're trying to create just chlorine by itself plus O2. So essentially a reaction or a collision has to happen for that O2 to be created. So that O just has to eventually hit the ClO in the right position for it to become the products.